Hello everyone, I am Han Yingche from Institute of Data Science and Knowledge Engineering, School of Computer Science in Beijing Institute of Technology. In this chapter, we introduced some useful platforms, Spark, MLlib, TensorFlow, and a typical big data analysis application recommendation system. And in this session, we will talk about social network analysis. In this session, we will learn social network analysis, the metrics of social networking analysis, and force-directed graph drawing. At last, we will do social network analysis hands-on. A social network is a social structure made of a set of social actors, such as individuals or organizations, and sets of dyadic ties and other social interactions between actors. The study of these structures uses social network analysis to identify local and global patterns, locate influential entities, and examine network dynamics. It characterizes network structure in terms of nodes, individual actor, people, or things within the network, and the ties, edges, or links, which is relationships or interactions that connect them. Let's watch a video about social network overview.
Social network analysis is the application of network theory to the modeling and analysis of social systems. It combines the tools for analyzing social relations and the theory for explaining the structures that emerge from these social interactions. Of course, the idea of studying societies as networks is not a new one, but with the rise in computation and the emergence of a mass of new data sources, social network analysis is beginning to be applied to all types and scales of social systems, from international politics to local communities and everything in between. Traditionally, when studying societies, we think of them as composed of various types of individuals and organizations. We then proceed to analyze the properties of these social entities, such as their age, occupation, or population, and then ascribe quantitative values to them. This allows social scientists to use the formal mathematical language of statistical analysis, compare the values of these properties, and to create categories such as low-income households or Generation X. We then search for quasi-cause and effect relations that govern these values. This component-based analysis is a powerful method for describing social systems. Unfortunately, though, it fails to capture the most important feature of social reality, that is, the relations between individuals. Statistical analysis presents a picture of individuals and groups isolated from the nexus of social relations that give them context. Thus, we can only get so far by studying the individual, because when individuals interact and organize, the result can be greater than the simple sum of its parts. It is the relations between individuals that create the emergent properties of social institutions. And thus, to understand these institutions, we need to understand the networks of social relations that constitute them. Ever since the emergence of modern human beings, we've been building social networks. We live our lives embedded in networks of relations. The shape of these structures and where we lie in them all affect our identity and perception of the world. A social network is a system composed of a set of social actors, such as individuals or organizations, and a set of ties between these actors that might be relations of friendship, work colleagues, or family. Social network science then analyzes empirical data and develops theories to explain the patterns observed in these social networks. In so doing, we can begin to ask questions about the degree of connectivity within a network, its overall structure, how fast something will diffuse or propagate through it, or the influence of a given node within the network. Let's take some examples of these. Social network analysis has been used to study the structure of influence within corporations, where traditionally we see organizations of this kind as hierarchies. By modeling the actual flow of information and communications as a network, we get a very different picture, where seemingly irrelevant employees within the hierarchy can in fact have significant influence within the network. Researchers also study innovation as a process of diffusion of new ideas across networks, where the overall structure to the network, its degree of connectivity, centralization or decentralization, are defining features in the way that innovation spreads or fails to spread. Network dynamics, that is, how networks evolve over time, is another important area of research. For example, within law enforcement agencies, social network analysis is used to study the change in structure of terrorist groups to identify the changing relations through which they are created, strengthened, or dissolved. Social network analysis has also been used to study the patterns of segregation and clustering within international politics and culture. By mapping out the beliefs and values of countries and cultures as networks, we can identify where opinions and beliefs overlap or conflict. Social network analysis is a powerful new method we now have that allows us to convert often large and dense datasets into engaging visualizations that can quickly and effectively communicate the underlying dynamics within the system. By combining the new discoveries in the mathematics of network theory with new data sources and our sociological understanding, social network analysis is offering huge potential for a deeper, richer, and more accurate understanding of the complex social systems that make up our world.
Social network can be presented using a graph. A node refers to a social actor, and an edge refers to a relationship. The weight of an edge measures how close the relationship is. Social network has low average distance. If we draw a social graph of everybody in the world, there will be more than 7 billion nodes. But according to 6 degrees of separation, the minimum distance of 2 nodes is very probably less than or equals to 6. Thanks to the development of Internet, the average distance of 2 nodes is going lower. Social network analysis is the process of investigating social structures through the use of networks and graph theory. Social networks and the analysis of them is an inherently interdisciplinary academic field which emerged from social psychology, sociology, statistics, and graph theory. Let us watch a video about what is social network analysis.
What is social network analysis? You've heard of social networks before, from the online versions like Facebook and Twitter to the more traditional social networks of people in a fraternity or in a small town. You've probably also heard about some of the interesting things you can learn about these networks when you analyze them. From silly things like hearing how many degrees of Kevin Bacon one actor is from another, or the slightly creepy like how Facebook's algorithms try to predict what products you want to buy or who to add as a friend. When you start to think about the world in terms of different overlaying networks that connect and transfer friendships, information, money, and power, you start to see how analyzing things through the analysis of social networks can lead to new realizations about culture, politics, history, and lots of other interesting topics. We have an intuitive sense that the connections to the people around us are a huge factor in what we know, how we think, and what we do. But researchers using standard statistical methods don't have a really good way to account for the effect of these connections without social network analysis. They can see similarities and differences between isolated data points, but social network analysis gives us tools to quantify those connections between individual points, often in a visual format, so that we can find patterns in the forces that connect us together as a society. We can find out how one person is connected or disconnected from people, groups, or trends in a population. You know those people who seem to be friends with everyone? Well, social network analysis can generate graphical representations that reveal individuals in a population that bridge different social groups. And ever had a friend who stopped hanging out with you once they got a new boyfriend or girlfriend? With social network analysis, you can study how individuals divide their energies between different social groups over time. We can study what makes a group of strangers start to form distinct friendship groups. And once networks are formed, we can see how things like power, beliefs, or even an outbreak of disease flows through the individual connections. As you can tell, there are practical questions that can get quantitative answers and new insights with social network analysis that just weren't possible before. This opens up an exciting range of new options. One example is in colonial American history. What do you think the social network of political leaders in Boston looked like at the time of the Revolutionary War? Duke professor Kieran Healy looked into this and found several distinct social groups, but one name that bridged them together: Paul Revere. Or in the topic of education, how are friendships in a school affected by race and age? In the data shown here, when we see friendships colored through grade level, it looks like there's pretty good diversity between the students of different class years. But when we look through the same friendships colored through race, the friendships start to look much less diverse. If we happen to combine this information with data from other schools, we can see what patterns keep repeating even in different environments, and what makes unique patterns arise. Social network analysis is a very open field, and there are lots of technical options to try out, like adding geographic mapping data to understand how physical environments change network dynamics. And for math geeks, it's still a very new field with lots of room for creating new analytical algorithms that can create new forms of mapping network connections. See the power of social network analysis in your own life right now by looking at the tools linked below to your Facebook, Twitter, and LinkedIn networks. You probably won't expect everything that you see, which is one of the reasons that social network analysis is so exciting.
Some metrics of social networking analysis. The metrics about nodes and edges include average clustering coefficient, eigenvector centrality, average path length, etc. The metrics about network include average degree, average weighted degree, network diameter, graph density, shortest path, heats, modularity, page rank, connected component, etc. Visualization is an important way to analyze the social network. Force-directed graph drawing is a good way to visualize the social network. Force-directed graph drawing is an important technology on social network visualization. Force-directed graph drawing algorithms are a class of algorithms for drawing graph in an aesthetically pleasing way. Currently, force-directed graph drawing algorithms are force atlas algorithm, Fruchtman-Reingold algorithm, if and who algorithms, etc. The basic theory is assuming that there are forces between nodes and feeds in physical models, and the goal is to make the whole system stable or has the lowest energy. Fruchtman-Reingold algorithm is one of the most commonly used algorithms. This algorithm uses electromagnetism theories and generates a circular graph. This picture on the left is the original graph, and the picture on the right is Fruchtman-Reingold style, which is more aesthetically pleasing. We will hands-on based on the data set of social networking of the movie Game of the Thrones using Network X and Galaxy. Network X is a Python package for the creation, manipulation, and study of the structure, dynamics, and functions of complex networks. Galaxy is an open source and free visualization and exploration software for all kinds of graph and networks. Experiment 1 includes loading data and generate graphs, network analysis, visualization using Network X, and edge bounding using data shader. Experiment 2 includes load data and analysis, graph simplifying using Friedman-Ringgold algorithm, and visualization and beautification. Experiment 3 includes social network recommendation, background citing, biased random walk, node representation learning, and recommendation. All the experiments material, including the manual and the codes, are provided on the platform, which can help you to do the hands-on. In this session, we learned the social network analysis. Thank you for your attention. If you have any question, feel free to contact me.